A swamp is an area of low-lying, uncultivated wooded land permanently saturated with water. There are two main types of swamps: freshwater swamps and saltwater swamps. Swamps typically exist in many kinds of climates and on every continent except Antarctica. They can be formed by flooded woodlands or former lakes or ponds overtaken by trees or shrubs. Swamps typically have a steady amount of rainfall throughout the year, with a slight increase throughout the summer months. They average about 175 to 200 centimeters of rainfall per year. Known for their tropical climates, swamps' temperatures typically range from 15 to 35 degrees Celsius. While freshwater swamps are commonly found inland, saltwater swamps are usually found along tropical coastlines. However, both saltwater and freshwater swamps can be found in tropical areas near the equator, which usually experience year-round heat and humidity. The soil within swamps are mineral soils with poor drainage. Because the water in a swamp is mostly still, dead plant matter settles at the bottom rather than being washed away. The slow replacement and lack of turbulence in the water results in a low rate of oxygen supply. Decay of the dead vegetation quickly uses up what oxygen is supplied, so that the mud and bottom waters are low or lacking in oxygen. There are several abiotic limiting factors to life, as plants in a swamp are often forced to compete for sunlight, nutrients, water, and space to grow. In terms of biotic relationships within the swamp biome, some examples of producers would include phytoplankton, duckweed, algae, and trees, while some primary consumers would include shrimp, snails, and small fish. An example of a secondary consumer would be snook, while an example of a tertiary consumer would be an alligator.
Common predator-prey relationships within the swamp biome would include the great anaconda and the capybara, the great blue heron and the white perch, and the American alligator and the white-tailed deer. To survive in the swamp, many wetland plants have adaptations, including special air or pore spaces in their roots and stems called parenchymas, through which oxygen can enter the plant and be transported to its roots. Some plants have hollowed stems that transport oxygen to the roots to accommodate for the lack of oxygen in the soil. Also taking into account the lack of oxygen in the soil, some wooded plants are able to pump oxygen from their stems to their roots. To optimize their water and oxygen intake, wetland trees have very shallow root systems, swollen trunks, and roots that grow above the ground. Examples of this are the cypress trees.
Just like plants, animals too must have adaptations to survive within this biome. Birds within swamps typically have longer legs and long beaks so that they can easily reach their food in the water. Animals with the ability to live on land and in water have webbed feet for moving through mud and water. The alligator in particular has a massive tail that helps it move and steer through water. They also blend into their environment with their dark, blackish brown color in order to effectively sneak up on their prey. In terms of human impact on the swamp biome, changed land use has led to the eutrophication of swamps due to increased nutrients in the form of sedimentation, fertilized runoff, and organic wastes entering swamps. These nutrients cause rapid increases in phytoplankton and aquatic plant growth. The high levels of organic matter
may cause massive deoxygenation of the swamp, resulting in a decline in water quality and the severe loss of aquatic life. To solve this problem, people can play their part by stopping using fertilizers on their lawns and not dumping waste in waterways. Acid rain pollution is also severely impacting swamps. The air pollution comes from many sources, including industry, power plants, and cars. It gets absorbed in the clouds, mixing with the rain. The rain falls and carries the pollutants. Since rain is a large source of water for this biome, and the biome itself is roughly 75% water, this is a major problem. Because nitrogen oxides, which create acid rain, are made in the process of burning fossil fuels, a way to reduce acid rain is to produce energy without using fossil fuels. Instead, people can use renewable energy resources, such as solar and wind power. A currently endangered species that lives within the swamp biome is the Florida panther. The Florida panther is a necessary element in regulating the swamp ecosystem. Predatory hunting by panthers helps keep the numbers of its prey, such as armadillos, deer, wild hogs, and raccoons, in balance. Panthers stalk and kill individual prey very selectively by scoping out the sick and weak animals, as well as the very old. This helps improve the health of the breeding population, reduces disease, and lowers the chance of passing on genetic defects. The Florida panther is currently classified as an endangered species. Due to excessive hunting that badly decimated the population, it was one of the first species added to the U.S. Endangered Species List in 1973. Characteristics that make the Florida panther vulnerable to extinction are that they have a low genetic diversity and are prone to contracting various diseases with high mortality rates, including feline leukemia. The current threats to the Florida panther include habitat loss, which is caused by construction, which reduces available habitat that is important to the territorial panthers. Also, Florida panthers are often hit by cars and killed by crossing roads and highways. Today, less than 100 panthers live in the wilderness of southern Florida, occupying about only 5% of their historical range. There are additional panthers living in human captivity, although the number is still small. The Florida panther is protected as an endangered species by the Federal Endangered Species Act and as a federally designated endangered species by Florida's Endangered and Threatened Species Rule. To recover the species, people are working to restore the panther habitats, specifically within the Everglades. Recovery efforts to date have successfully contributed to a significant increase in the panther population. The range expansion and reintroduction of additional populations of panthers are widely recognized as essential for recovery. Similarly, fostering greater public understanding and support is necessary to achieve panther conservation and recovery.